Okay, let's take a look at problem 1 here. We have a normal population with a mean of 513 and a population standard deviation of 72. So here we go. A normal population with a mean of 513 and a standard deviation of 72. And we want to know the likelihood of getting a value above 550. So that's 550 right there. We're looking at the area beyond that. So we'll calculate the z-value, which is just the number of standard deviations above the mean. So x minus mu over sigma, or 550, minus 513, again, just how far away are we from the mean, in x units, divided by the standard deviation to get this in z units, and that comes out to be 0.51. So that means the value is about a half a standard deviation above the mean. Then we look up an area in the z-table based on this z-value, and you should have gotten 1950. So that's this part, 1950 is in here. So the area we're interested in is going to be 0.5 minus 0.1950, or 0.3050. Okay, for part B, we want to go from 400 to 450. So we're going to go from 400 to 450. So we're interested in this area. Well, we can't get that directly because we have to go from the mean to some point. So we can take this area, which I'll call area A, and this area, which I'll call area B. And then the difference between those is going to leave the area that the area of interest. So we'll get ZA is equal to x minus mu over standard deviation. So 400 minus 513. I'm sorry, 400 minus 513 over 72. And that's minus 1.57. The minus just means that we're below the mean. That we're so little more than 1.5 standard deviations from the mean. If we look up the area for that in our z-table, we will find 0.4418. And so for area for B, again, the number of standard deviations from the mean. This time it's 450 minus 513 over 72, and that's minus 0.88, so not quite a standard deviation below the mean, and we get 3106. And so that's area B. And of course, to get the area of interest, we're going to have to take the difference between those. 4418 minus 0.3106 is 0.1312. And that'll be the answer for that part. So in part 3, we're looking for the 90th percentile. So we're looking for a value such that 0.9 or 90% fall below that point. Well, we know from here down is 0.5, and so the area from the mean to the value of x that we're interested in is going to be 0.4. So now we're working backwards when we do the percentile problems. We need to go into the center of the z-table and find a value that's close to 0.4. So looking in the middle of the table, the closest value you should be able to find to 4 is 3997. So that's the area. Instead of like the other problem, starting at a standard deviation and finding an area, this one we're starting with an area. This is in the center of the table, and back your way out you're in the row 1.2 and in the column 8. So this point x is the mean plus 1.28 standard deviations. It's just the number of standard deviations above the mean. That's just a z value. So then it's just plug in some numbers now. And that all comes out to be 605.16. Okay, in part 4, now we have a sample size of 4, and we're asking about sample means. What's the probability that we get sample mean greater than 550? Those are the two clues that we're looking at a problem where we have a distribution, a sampling distribution of x bars, and via the central limit theorem, what we know is that the mean of those is equal to the mean of the population, so that's 513. By the way, since the population is normal, even though that's a small sample size, this sampling distribution will be a bell curve. If the population were not normal, you'd need a larger sample size depending on whether you have skew, outliers, or extreme values. But that's getting ahead of ourselves here. So we have this mean of the sampling distribution is 513, but the standard error is equal to the population standard deviation divided by the square root of n. And our standard deviation was 72 divided by the square root of 16, and that comes out to be 36. Now from here, the problem has worked pretty much like we haven't done our other problems. We're looking for above 550, a sample mean above 550. So we'll get a z value, but this time it's x bar minus the mean of the x bars, because that's the distribution we have, divided by the standard error, or standard deviation of the x bars. 550 minus 513 divided by 36, and that comes out to be 1.03. And if you have a z value of 1.03, that's going to give you an area of 0.3485. And again, that's this area in here. That's the 0.3485. And so the area that we're interested in, that we have shaded over here, above 550, is going to be 0.5 minus 0.3485, or 0.1515. And that'll be the answer to that. Okay, in this video, I'm going to look at using your calculator to get check figures, or if you're doing a multiple choice, you can get correct answers this way. In some cases, you'll see that the rounding is a little bit off because, well, the calculator doesn't round, but should get in the ballpark for all of the problems. Well, on number 1, we had a population mean and standard deviation of 513 and 72, and we wanted to know the probability of getting a value above 550. So for that, we can go to second and distribution and go to normal CDF, and the lower value, we want to go from 550 up, it will be 550, and then our upper value, well, you could just put infinity, but if you just put any like huge number there, that'll be good enough. And then the population mean was 513, and the population standard deviation was 72. And this basically just pastes the value into here. If your calculator doesn't have the menu like that, you just put when you just put that command in there, you would put the lower and upper limits that you're looking for, followed by the mean and standard deviation, separated by commas there. And there you have 0.3036. Using the table, we got 3050. So we're in the ballpark on that. In part B, we had the same stuff, but we wanted to go from 400 to 450. So again, second distribution, and then we'll go to a normal CDF, and our lower was 400, and then we had 450. The next two were the same, and so we just hit there, and we got 0.1325. When we did this by hand, we got 1312. Again, the calculators are actually a little bit more accurate. Well, here, I guess I could show you this, a second distribution, and this time we'll shade the norm. And let's see, we had 400, 450, and 513 and 72. And you can see that it'll actually draw the curve for you as well. On part C, it asked for the 90th percentile. So for this one, you can do second distribution, go to inverse norm, and okay, this one, sometimes it gives me a menu and sometimes it doesn't, but it doesn't make any difference. We want to say 0.9, that's the percentile that we're looking for, and then we put the mean and the standard deviation, and sorry, that should have been, and close the, well, sorry, I should have just, here we go. Okay, so you actually don't have to close the parenthesis, but I feel morally obligated to do so. Okay, and so that tells you, remember we had 605.16, so 605.27 maybe is a little more accurate there. Okay, I was messing around with this, and I did it again, and this time I did come up with a menu. So my area is 0.9. And let's, instead of putting in the, leave this 0 and 1, the default, and go there. And what we'll get now is that z value of 1.28155. And let's see what happens if I do this again. To inverse norm. Okay, I'm getting the, remember we had 513 and 72. And now this time, of course, it gives you the final answer, the value of x. So that's just the same thing, and wanted you to look at that inverse norm thing. And on part D, we would do it the same thing, except for make sure that you enter 36, not 72, because we're doing a problem with the standard error there. So second distribution, normal CDF, and we were going from 550 to some really big number, however you want to do that. That's way more than enough. 513, 72, paste, and oh, well, okay, so what did I do? I got in a hurry and said put 76 there instead of the 36. Okay, let's go second distribution, normal CDF, and I wanted to go from 550 up, and I had 513 and 36. Remember, you got to put in the right thing there. You won't get the right answer, and so 0.1520, and I had gotten 0.1515 with the table. So this will be just a little more accurate on that.